Okay. How to solve a linear system using the substitution method. So we have two equations with two variables, x and y. They share the same variables. Since one equation is solved for y, we're going to take the value of y, 5 minus x, and since it says y equals, we're going to substitute for y in the second equation. So now that becomes 2x plus 3, and y turns into 5 minus x equal to 5. So now we have one equation with one variable. That variable is x. So to get rid of this parentheses, we're going to distribute the 3. So we have now 2x plus 15 minus 3x equal to 5. Since I have two terms that are alike, one's positive, one's negative, I can make some zero pairs. So I'm left with 15 minus x equal to 5. I want to get the x by itself, so I'm going to add negative 15 units to both sides. So negative x equals negative 10. Yes, I had to bring down the negative with me. So what's in front of the x? An invisible negative 1. So I'm going to divide by a negative 1 on both sides, since negative 1 is the coefficient. And x equals positive 10. Now, I started with two equations, two variables. So far, I have only solved for one variable. So I'm still missing to solve for y. Which of the two equations looks easiest to you or me? In this case, it would be the first one, because it already says y equals. So I'm going to copy that equation here to the side. I'm going to take my value of x, and I'm going to substitute for x. How do I know? Because it says x equals. Y equals 5 minus 10. So a negative invisible 1 times 10 gives me negative 10. So 5 minus 10 now becomes negative 5. So now I have a value for x, which is 10, and a value for y, which is negative 5. If I was graphing this, that would mean that the lines would intersect at 10, negative 5. But since I am not graphing, I say, therefore, the solution, instead of saying the point of intersection, for the system is 10, negative 5. A common mistake that I see students do is write their answer backwards. Remember that x comes first and then y.